Here is a dashboard, a heading, 3 rows, and a button. It is on screen, it looks finished, and it does not work. Watch, click, nothing. Click again, still nothing. And now it works. Nothing was broken here, no error fired, and no request failed. That finished looking button sat on screen, doing nothing at all for well over a second. Now, here is the same application, built the other way. Same dashboard components, same data. Look at the same moment. There is no button yet. There is nothing on the screen at all. Two versions of one page. One shows you something you cannot use. The other shows you nothing yet. Neither one is a bug. For this first page load, the difference begins with one decision. Who produces the initial HTML? In a conventional React single-page application, the answer is the browser. The server sends a nearly empty page and a bundle of JavaScript, and the browser assembles the interface. That is client-side rendering. The other answer is that the server turns your components into markup and sends that markup ready to read. That is server rendering. React does both, and Next.js is one framework that coordinates them for you. So, let's run one application both ways and measure it in a real browser. Start with what actually arrives, because it is the smallest honest place to look. This is the document the client rendered version sends. Compressed, it is 84 bytes, and not one word of the page is inside it. An empty root element, a script tag, and nothing to read. Now the server rendered document. Compressed, 265 bytes, and the heading, the rows, and the button are all in there as plain markup before any client-side JavaScript has run. Before either page has executed any JavaScript in the browser, the difference is already sitting inside these two responses. That difference explains most of what we are about to see. So follow the client rendered page along the top lane. The document arrives almost immediately because there was nothing to wait for. Then the browser sees that script tag and asks for the bundle. It downloads it, and on a throttled connection, that download alone is the longest single stretch on this lane, then passes it and runs it. Watch the browser build the interface from JavaScript. Only then does the application ask for its data. The rows have to come back before there's anything to draw. And when the code and the data have both arrived, React creates the elements and puts them into that empty root, which means everything on this lane is stacked end to end. Bundle, then data, then content. Until the last of those finishes, the window is blank, with nothing on it to say whether anything is coming. Now the second lane. The server renders those same dashboard components into markup and sends the result. The browser still fetches, still passes, still works out the layout and paints it. It is doing the same job it always does. What moved is where those elements were first created, and the content is in the page several times earlier, from the same application, the same data, and the same browser throttling. Look at what the top lane is doing at that moment. Still blank. Now both versions pay for that same data. What changes is when. In this non-streaming test, the server could not send its first byte until it had the data to render with. So its response starts later than the other ones. The client rendered page did not wait at the start. So in this implementation, one side pays for the data before it can send the page, and the other pays after the bundle has already downloaded and run, extending the chain at the end. Now here is the part that changes what this is for. Go back to that button. On the server rendered page, it is on screen almost immediately, and the first click that does anything lands near the far end of the lane. For well over a second, a finished looking button did nothing at all. Here is why. The markup came from the server. React's event handlers did not. They arrive with the bundle, exactly as before. When that bundle runs, React walks the markup already on the page and attaches its handlers to it. That step is called hydration. At the moment we clicked, the bundle had not arrived and hydration had not even started. The button was visible markup, but React was not listening yet. Our probe attempted a click once per animation frame, and across all 10 runs, every click made before the bundle arrived was lost, not queued, not replayed later. Gone. So, does moving the work to the server mean less JavaScript? In this experiment, both versions downloaded the same client application, about 50 kilobytes compressed, built separately, one entry for each mode, and the difference between them came to under a tenth of 1%. The server rendered page needs it for exactly the reason the client rendered page needs it, to make the interface respond. What changed here is when you can see the page, not how much you download. And that is worth being careful about because it depends entirely on how the application is written. Move work behind a server boundary, server components for one. And the client bundle really can shrink. But that is a different mechanism and not this video. What we measured is one honest case, the same component tree running in the browser either way. One more comparison, and it is the one that makes the document real rather than theoretical. Turn JavaScript off completely and load both pages again. The client rendered one gives you an empty body, literally nothing. The root element is there, and it has no children. The server rendered one is still readable. The heading, the rows, the values, all present because they were in the response before any script ran. Readable is the right word to use there. Nothing on that page answers a click because the handlers never arrived. But a reader or a client that does not run JavaScript at all still gets the content. That is not an argument about search rankings. It is just what is in the response. So put the two lanes side by side and read them honestly. The moment the content entered, the page moved a very long way. The moment the interface actually answers, a click barely moved at all. Both versions landed in the same band, and across repeated runs, neither one was reliably ahead. So server rendering did not automatically make this page usable sooner. It made it visible while the client was still getting ready. That gap between visible and usable is not a side effect of the choice. It is part of the choice. So the rule worth keeping: server rendering can put the interface on screen before its JavaScript is ready. It does not on its own make that JavaScript ready any sooner. It changes what the server sends, when content can appear, and what the person is looking at while the client gets ready. It is not a speed switch, which means you decide it per page by asking one question. While this page is getting ready, what should the person see? The real content before it is interactive. A loading state that honestly says it is not ready or nothing at all. There is no answer that is right everywhere. There is only the one that is right for that page. Streaming can change when the server starts sending the page, and server components can change how much JavaScript reaches the browser. Different mechanisms and their own videos. If you like seeing how the web actually works, subscribe. That's what Code Seeker does.